Next up, we have Ben Pingault, a postdoctoral fellow at Harvard University, representing the Center for Integrated Quantum Materials, which is working to create atomic-scale building blocks that could pave the way for powerful quantum computers and communication systems. Take it away, Ben.
Computers are everywhere these days, from our smartphones, laptops, all the way to supercomputers. And they help us so much processing information, solving complex problems. So there's a big incentive to improve them and make them even more efficient, right? Well, what if I told you that maybe one way of making them much more powerful was to use the weird rules of quantum mechanics? The weird laws that rule over the world of tiny objects, such as atoms and electrons. But now, what if I told you that this computer of the future using quantum mechanics could actually be made of diamond? Let me tell you. But first, I need to shrink myself down to the size of a much smaller than a grain of sand, all the way down to the size of a single atom, those tiny particles that constitute all matter. And now I'm ready. Let me jump into the diamond. And now I'm surrounded by all the carbon atoms that constitute the diamond. But I'm not a carbon atom. I'm another type of atom. I'm special. I'm a tiny defect. And I have this very peculiarity. I have a tiny magnet with me. It can be pointing upwards or it can be pointing downwards. And that could be used to store information, like in today's computers, in successions of zeros and ones. So upwards could be 0 and downwards could be 1. But that's a special magnet. That's a quantum magnet. And in quantum mechanics, it says that something can be in several states at the same time. That's the spooky thing about quantum mechanics. So my tiny magnet could be pointing upwards like a 0, pointing downwards like a 1, or both at the same time. Aha. But what does it have to do with computing then? Well, if you have a normal computer program like in today's computers, you want to know what it does. And so what you do is you have an input and you feed it into the program and you look at the answer. Then you feed another input into the program and you look at the answer. So you see, it took me 2 turns to know what the answers are. But with a quantum computer, you can feed both at the same time and you get the answer. So just one run. So if you have 50 inputs, say, you can all process them at the same time. So you speed up things so much that a very, very complex problem that would take years to solve on the best supercomputers today could be just solved on a quantum computer in a fraction of a second. And that has huge implications, especially to solve very complex problems such as predicting reliably the weather forecast, understanding complex biological molecules and how they interact with each other, or even optimizing air traffic in real time, which is very complicated. So let's get back to our diamond. Obviously, I can't do all of this all by myself with my tiny magnet. I need other ones like me to process all that information. And look, there's another one over there. But how can we communicate? Well, because diamond is transparent, you can actually use light. And this way, you transfer information between those tiny magnets across one defect to the other, and all together, we can compute information using quantum mechanics and speed all this up. So to conclude, the diamond is just like people. It's their defects that makes them interesting. Thank you.